Hi guys, good morning. Thank you for being here for my session. So what we're going to be talking about in this talk is we're going to be picking up some of the big data services from Amazon, Azure and Google Cloud, and we're going to compare them and see which one is better, right? Or at least try and see which one is better, right? So a little bit about myself. I work at Patin as a project engineer. I've done multiple things in my career. I've been cloud architect, been database administration, always been into automation as well, and I'm also a Google authorized trainer as well. Right? I've done a lot of certifications, which is kind of something that we do at Patin. I mean, they organize stuff for us, and we go and get certifications done. Right? And I love doing certifications, so I mean that's why the list is right. So, what are we going to discuss? So, on the agenda, we have a certain set of big data services from different cloud vendors, right? And we're going to look at the ingestion services from Amazon Cloud, Microsoft Azure, Google Cloud, which is their streaming ingestion service or their batch ingestion service on how you store data, their object level stores. Then we have where do you store the data, be it a data warehousing service or be it an object level store here as well. And then we see how to process and analyze that data. What are the various services that helps us analyze and process all of that data, right? So this is not an exhaustive list of all the services that's there, right? So this was actually quite difficult to prepare this. So when I signed up for this, I was like, you know, okay, I can do this. But later on when I was preparing this, there was so much out there that putting an all exhaustive list was simply impossible for me to do, right? So what I've done is I've put together a comparison of equivalent services of all different vendors that I know of, right? And I've tried to compare them from the perspective of cost, performance, and some of the key features, right? And then, you know, we'll see which one is better than the other one, right? So, first of all, we'll look at some of the data ingestion services, right? But before we go into that, I'd like to explain what are the different types of workload, what are different types of data. Data can be categorized into application data, streaming data, or batch processing data, right? So application data is data that is generated by an application. Think of an e-commerce website, the orders data, the customer's data is generating, right? Or mobile devices, the data that is generating. So that's all application data that we store into DBAAS or a NoSQL solution. And this is what we're not going to talk about here, right? What we're going to focus on is on streaming data and batch processing data. So what's the difference between streaming data and batch processing data? Streaming data, we talk about data that's always flowing. Think of data published by traffic sensors or IoT devices, and that's coming in, and we want to analyze that data in near real time or real time, right? So that's streaming data. Right? We'll look at the services that offers this type of ingestion and processing in the cloud vendors, right? And then we have batch processing, which is large amount of data, historical data, unstructured data, or structured data kept somewhere that we want to analyze, right? So that's batch processing data, and we'll look at how to store that and analyze that into different cloud vendors. Right. So from there on, we come to different services. So Amazon offers S3, simple storage service. Google offers their own object level store, which is GCS, and then Azure has their own blob storage, right? So for this particular comparison, I've not compared the Azure premium storage. So I've left that part out because I wanted to be fair to Azure as well, because the premium storage would have been a lot costlier and the comparison would have been like totally out of the box, right? So I've compared some of their features, right? So, for example, the SLA, both Azure and AWS offers a 99.99% availability SLA. When it comes to durability, they have pretty much the same 11.9 durability across all the cloud vendors. When it comes to handling the hot data, we have S3 standard, cloud storage, GCS there's multi-regional and there are regional buckets to handle that, and we have hot blob storage in Azure to manage that, right? And they do offer something for data archival or cold data. We have Glacier inside of Amazon, we have cold line storage in GCS and cold blob storage in Azure. They can all store unlimited amount of data. When it comes to hotspotting, now this is where Google actually wins, right? when you have non-random prefixes, you will see hotspotting issues inside of Azure and Amazon as well. But Google actually wins over here because they don't have any hotspotting issues, even with non-random prefixes that if you might have that. Now, coming to the third-party integration. Amazon has a very high third-party integration as compared to Azure and Google at this point in time, right? So we've seen that most of the vendors supports Amazon out of the box, and they will be supporting the other vendors, but it's not supported at this point in time. Now this is going to change, but it is what it is at this point in time, right? Now, when it comes to geo-redundancy, data that has geo-redundancy, Amazon, you can configure it using a feature called cross-region replication, but Google and Azure has simply provided it as a service. So it's there, you can simply use it and don't have to configure anything additional to that, right? With Amazon, you can do it, but there is an extra feature called cross-region replication, which you will have to utilize this. Now, some of the features that I haven't mentioned over here where Amazon stands out is object-level versioning, where the other vendors, they don't have something called object stacks, so they have no concepts of that, where Amazon does have that, right? When it comes to managing multi-part uploads, you have to write the application logic for GCS, but in Amazon, the multi-part upload API handles it out of the box. Other stuff like object-level labeling, which is supported by Amazon, it is still not supported by GCS, right? So Amazon does stand out in some ways when it comes to using S3. It has much better features, it is much better integrated, right? So it does stand out than the other vendors, right? Let's compare them and see, which performs better, right? So how do you know which object store performs better, right? So I decided to pick up 3 key parameters and compare them on those parameters. Total capacity versus the system load inside the vendor servers, right? Technology and software they use for transferring data, and then of course your internet speed as well, right? So if you combine all of these parameters, we can actually come to a point where we can decide which one performs better, right? So what I did was I took certain objects and uploaded them. Some large files, some small chunks of files, and we uploaded them to Amazon, Blob storage, and GCS. And it was found that in GCS, the large files were 2.5 times faster when we uploaded them, and the other one, small files, were 10 times faster when it comes to uploading the data to. Now, which one is cheaper, right? So you'll see that the storage cost in Google Cloud is cheaper, and if you talk about a geo-replication, data being geo-redundant, then that also is cheaper in Google Cloud Storage. And when it comes to storage cost, cold storage, archival data cost, then that's kind of similar for both Amazon and GCS, and Azure is a bit higher in that case, right? So we ran some tests, collected some data for our customers, and we calculated the cost. And overall, what we figured out that GCP storage is 35% cheaper than the other vendors, right? So it is cheaper, but the drawback over there is the features that we get in the other vendors, right? Because GCS is still evolving when it comes to offering lots and lots of features. It has evolved a lot, but it is still evolving. Right, so that was where we would keep our batch data. Now, what about streaming data? Now, Amazon supports Kinesis. Event Hub is supported in Azure for processing streaming data, and then we have PubSub inside of GCP for supporting streaming data, right? So some of the features that's listed over here, they all guarantee at least once delivery of your messages or your stream workloads. So that's there. Now, when it comes to guaranteeing the order of the message, first in, first out, it is not supported in GCP whatsoever, right? You can assure that within a particular partition or within a particular shard, which is a way of partitioning messages inside of these queues, there is an ordering guarantee, but there is no ordering guarantee when it comes to processing a particular multiple shards, multiple partitions. When it comes to throughput, both Azure and AWS supports 1 Mbps input and 2 Mbps output of throughput, whereas Google claims to have unlimited throughput, and the default is 100 Mbps input and 200 Mbps output, right? All of them has a persistent period of 1 to 7 days. With Google, you don't have 1 to 7 days, it's 7 days de facto, you can't change it, right? And when it comes to partitioning, yes, they all support partitioning. Now, Amazon has their own concept of partitioning. They're not having the concept of Kafka. They call it shards, but what it is underlying is really a partition. Now, when it comes to replication of this data, both Azure and GCS, both PubSub and Azure's Event Hub, they are both global, provided what tier of service you're using. Right, PubSub, they don't have a tier of service, but Azure has standard and the free tier. If you're using the standard tier, you get replication across multiple regions, which means that you have high availability, right, and redundancy as well. But when it comes to Amazon Kinesis, it only supports redundancy within a particular region, within multiple data centers in one region, right? The max size of data set is 1 MB in Amazon and Azure Event Hub, and then Google PubSub supports a max size of 10 MB. They all support push method, but Azure Event Hub does not support a pull method, where the subscriber could pull a message, right? Scaling. Now, Kinesis, like I mentioned earlier as well, is only regional, whereas both PubSub and Event Hub could be multi-regional or even global as well. Now, all of them has a millisecond to second latency if you're using a push method, which is good if you're trying to build a near real-time or a real-time application using these type of ingestion services. Now, we tried to compare the performance, and it was really difficult, but then we boiled it down to the latency, right? Okay, what's the latency like, right? And based on that latency and the time measured, we decided that, okay, based on this, we can say which one performed better. And during some of the comparison that we made, all of them actually performed quite okay, right? So there was not a winner over here. They all performed based on what kind of workload you have. They all performed okay, and all of them showed a millisecond to second latency, which was fine, right? So there is no winner when it comes to performance. But when it comes to pricing, we looked at their pricing, we ran some workloads, and then reviewed the bills later on for some of our customers. And what we figured out was that the latency was okay up to the mark, but when it comes to cost, PubSub was significantly it was a lot costlier than Kinesis. Kinesis and even Event Hubs, they are also costly, but PubSub stand out to be the most costly service from GCP, right? Whereas Kinesis and Event Hubs were fairly cheaper than PubSub, right? Now that we have ingested our data, we know how to process streaming workloads and batch workload. Now let's look at processing data. What are the various services that these vendors offer when it comes to processing this data? So we have Kinesis. We have Kinesis Data Analytics. That's a service. Kinesis has multiple services. There's streams, there's video streams, there's data analytics, right? So this is Kinesis Data Analytics. Then we have ASA from Azure, and then we have a data flow from GCP, right? They all support native machine learning that each vendor has. They are all serverless, no ops solution, which means that you don't have to worry about provisioning servers. They scale automatically. They have sub-second to low latency, all of them, right? But where did data flow stand out was that it also supports batch processing. So just one service to support both streaming data and batch data. So when you come to batch data, let data flow run, process your data, and it's done. No cost afterwards. It's job oriented, fully job oriented. Of course, when you're using streaming service, this needs to continuously keep running, right? But having one workload, one service to process all of your jobs is really a nice idea, right? Which is where GCP actually wins here when it comes to video streaming. Now, not all the workloads that we have are really, streaming workloads. What about batch data? Right? Now, this is where the historical data would be put on the object level store, processed, and then put back on the object level store, the output itself, right? Now they all support Hadoop in their services, right? They're all open source. There is native integration with applications. They are all open source. There is elasticity and flexibility. So all of that is supported. The services are Amazon offers EMR, Elastic MapReduce, where DataProc is supported by GCP and HD Insight is supported by Azure, right? So they all support Hadoop ecosystem, which is all open source. Now, how to decide? The features are pretty much the same, right? So how to decide now which one is much better, right? So we created exactly similar or near similar instances because in GCP you can control the size of the instances, but in Amazon or Azure you have to pick a size that they have to offer, right? So we picked up certain categories of instances which is kind of equivalent, right? We created some workloads, we processed those workloads, we put some Hadoop jobs, some Spark jobs, some PySpark jobs, processed them, and what we figured out was that all of the jobs that we had, they took the same amount of time. Of course, Azure performed a bit better in our analysis, right? But they were quite similar, which is kind of understandable because underlying they all run Hadoop, right? So it was okay. I mean, there would have been a very big difference for this 10 GB data set that we ran, right? I would have been worried because then I would have been like, there's something wrong with the kind of analysis I'm doing. But they all returned the same amount of time to execute the jobs, which was okay, right? But when it came to cost, GCP actually was a lot cheaper. It was, you know, the cost for GCP was literally, you know, a lot cheaper than the other vendors, which is where I thought that, yeah, DataProc can actually save you money, right? How? Their job first approach is something where I think why DataProc is a game changer. Now, of course, that, you know, I mean, the other vendors can also have job first approach, but GCP actually say that you should use DataProc for job only approach. How? What they're saying is store the data on GCS where you have a petabit scalability and you can process the data, you can pull the data from GCS with a petabit bandwidth into the Hadoop cluster, DataProc, and then process it and save it back to GCS, right? You can spin up a DataProc cluster within less than 90 seconds. Process your job, shut down the cluster. So you're paying less now. You're only paying for the amount of time where you have, you know, processed your job, and that's it, right? One of the good features about DataProc that I really like is that it supports the custom virtual machines as well, where you can say that, okay, this is the amount of RAM and this is the amount of CPU that I need for this instance, and be done with it, right? Rather than having to pick up an instance that the vendor will support and having to pay more for the resources, which actually you might not need, right? They scale up faster, they scale down faster, which is great as well, right? And the other thing is that we also get support for preemptible VMs, which are like 24 hours availability VMs, which will shut down after 24 hours, which is actually 80% cheaper than the actual virtual machines that you'll be paying for. Plus, they also offer you sustained use discounts, which is if you use the VM for like 30 days, they'll offer you 30% discount. Just like that. I mean, no additional configuration, no reservation, nothing, no commitments, nothing. They'll offer you a 30% discount. Which is why I think that their approach towards doing batch processing is much better than the other vendors. Right? Now, coming to the data warehouses. Right? So, they all support their data warehouses. They all have a solution for that, right? And it was really tough to do this analysis and compare these data warehouses, right? Because one had to offer something better than the other one, right? Something offered, there was a GCP offered something which the other two did not offer, but AWS and Azure offered something which GCP did not have to offer, right? So we tried to do the analysis and we tried to compare them, but you know, I won't say that this is a good comparison, because the comparison for this will depend on your workload. Is it predictable? Is it unpredictable? And then what kind of data that you have, right? Based on that, you can pick which one is better for you, right? But I try to do a very, you know, generic comparison between all of these data warehouses. right? Before I go and compare those data warehouses, you'll be surprised to know that how many people have a confusion with, online analytical processing data and then, transaction processing, right? So I try to explain that, right, with an example. So a person goes to a beer shop, he purchases a beer, he made a transaction, that's OLTP, right? And now that data collected over past 1 year, we are trying to analyze that data to find out that how many particular brand of beer was sold in a particular month. That's analytics, right? And there is a difference on how this data is stored, which makes it perform better in case of a data warehouse. Now, in a data warehouse, we have a rows versus columns stored, which is OLTP supports row stored, where we store data in terms of rows, where data is stored together in terms of rows, and with data warehouse, we store it in terms of columns, where it is sequential. The data is stored sequentially, column-based, right? Which makes data warehouses very good for reads. They perform a lot better than reads, but when it comes to writes, they perform poorly, right? And I mean, you can write to them, but when you actually do updates, they perform very poorly, right? So it's not recommended that you actually update the data in data warehouse. You can do it, but it will be very slow, right? Because of the column store technique that data warehouse uses. Now, coming to the comparison between Redshift versus Snowflake versus BigQuery. Now, Redshift is one of the most tunable most tunable system that we found out it to be, right? Whereas Snowflake is more of a hybrid system, right? Whereas BigQuery is a 100% shared distributed system, which means it's all shared, right? It's again their job first approach. Where when you talk about Redshift and Snowflake, you're really spinning up something, where BigQuery is totally no ops. No servers, nothing, you simply process your jobs, the data that you have, and you get the output. So fully 100% shared distributed system, right? Which is why the comparison was different, and I'll explain that when we move to the next slides. When we talk about elasticity and scalability of these three different services, Redshift is the clear, loser here because it takes hours to scale up Redshift, whereas Snowflake and BigQuery, the elasticity is, either fast, and with GCP, it's query based. Based on your job, it will just scale like anything, right? Based on what your requirement is. And it's all mobs, so Google will automatically scale it and allocate resources on the go. When it comes to availability, for Redshift, you can take a backup, which is not the best approach out there, right? Whereas both Snowflake and BigQuery are distributed systems, so data is always, replicated across. So Snowflake does offer JSON support. There is no JSON support in Redshift, where as in GCP, you can have something called user-defined functions, which can help you have JSON support. Now, if you're trying to tune your where clause inside of Redshift, there is a sort key operation on how you can do it. There is partition by in Snowflake, how you can do it. Whereas in BigQuery, there is nothing. You can partition your data, but that's like partitioning, but not something that where you can actually tune your where clause itself. Can you tune joins? No in Snowflake and no in GCP BigQuery, but yes, you can use this key operation to tune your joins inside of a Redshift. So the Redshift that we compared over here, I like to explain that we haven't considered Spectrum over here, right? Because one of the reasons for that was because of my knowledge and my I've never worked with Spectrum before, so I decided to leave this out. What I did was I tried to use Redshift as a fully metal-most system that we run all across the day, right? So that's what I tried to do over here. But all of them offers different pricing schemes, and we'll see how we compare these pricing, right? So with Redshift, you run nodes. You'll be paying for compute and that storage that you have allocated across, right? With Snowflake, it's pretty much the same, where you can actually shut down the cluster or the Redshift, the Snowflake cluster and save money during the periods of inactivity, which is totally automated by Snowflake, right? So if not having a lot of activity, it will simply shut down, right? Whereas BigQuery is totally different because it is no ops and it will only invoke when you actually run a job. So you will be only paying for storage and you're not paying for any compute over there, unless you actually run a job, right? So it was very difficult to do the price comparison, but we still decided to go ahead and do it. And I'll show you the next slides on what was the final verdict of which was cheaper than the other. Right, so we decided to use TPC OS standards. We used this to perform a data warehousing benchmark, and this is the most commonly used data warehousing benchmark that we have out there. So we decided to use that. Now, I understand that other vendors, they have also published their benchmarks out there, right? And I've read those blogs, I've gone in and read those, and what I figured out is that most of them have actually used TPC OS, whereas the vendors themselves, they have not used TPC OS, and they've used the largest instance type that you can have, and then they have to perform those benchmarks over there, which I don't agree. Some people might say that, okay, those are correct, but I don't agree with those benchmarks because, again, they were actually, more inclined towards showing that their service is better, right? So I tried to be fairly, honest here and be fair to all the different vendors here. So we did some benchmarks of 99 TPC OS queries, and what we figured out was that all of them actually perform very well, right? So Redshift was a bit slower because of their slower query planner, but apart from that, there was no major difference when it comes to performance. And again, when I did this analysis, I was actually happy with the analysis. Why? Because if there would have been a big difference, I would have been like, yeah, okay, they're all data warehouses, same amount of data. If there was a big difference, I would have been like, yeah, okay, there's something wrong that I'm doing here, right? But since they all performed good, they all had average execution speeds for the workload, I was like, okay, yeah, this data that I've collected is good, right? Now, when it comes to cost, now how do you compare cost? Now, this was difficult. Like, this was actually very difficult to do. Reason being because how do you compare cost? For Redshift, you have a cluster, a full-scale cluster running all the time, and you're paying for the compute and you're paying for the storage, right? So you're paying for both. Whereas in Snowflake simply shuts down when there is inactivity, but as long as it is active, you're still paying for both compute and for storage. Whereas in BigQuery, you're only paying for storage because you're not running anything. For the for the time period where you're not running anything, BigQuery doesn't charges you for query, right? But when you actually submit a job or you actually run a SQL like query on BigQuery, then you get charged for it, right? So how do you compare them? Because one is running all the time and one is only charged when you actually submit something. So how do you compare the cost? So what we decided to do was that we ran some workloads for a period of time and we only compared the cost for the time of activity. So we have not compared the cost over here, just to be fair for all the vendors, we have not compared the cost here during the time of inactivity, right? So the cost here that we have compared is on the fact that, okay, during a period of 10 hours, all of these servers are fully used, there is activity, we are running reports, there is warehousing that's running on these, and the cost has been compared as such, right? You'll be surprised to know that a lot of data warehouses are actually only utilized 20 to 30% across the whole day, which means that you're actually losing money on the compute throughout the day, right? Which is where, BigQuery could be great because it's very suitable for unpredictable workloads. But what if you have predictable workloads? Based on the analysis that we ran, BigQuery can be way expensive than Redshift or Snowflake. It's very expensive if you have a predictable workload. If you say that, okay, 10 hours of workload, we know that we're going to be using this 10 hours of workload 100%, right? It's predictable. We know what we're doing. BigQuery is going to be very expensive for you. But if you're using Redshift or Snowflake, it will be a lot cheaper, right? But the only differentiating factor is that we actually never utilize a data warehouse 100% of the time. right? So we are paying for the time and for the compute that we are actually never using, right? Which is where BigQuery can actually win. But if you actually compare the cost, BigQuery is way costlier than the other vendors, right? So the final verdict on this data warehouses, right? So BigQuery is a shared resource query service, so it's totally no ops and it's totally serverless, it's shared and distributed. There is no equivalent configuration to this, right? So it was very difficult to compare this with others. Now, if you have predictable ongoing workload, I would recommend that you use either Snowflake, actually Snowflake, then Redshift, but yeah, both are there, right? So you can use Redshift or Snowflake for predictable workloads where you know that, okay, this is going to be my utilization throughout the day, so I'm going to be picking up and using the service. When it comes to ease of use, Redshift, it requires a lot of tuning and a lot of parameters that needs to be changed. And whereas the Snowflake and BigQuery were fairly easy to use, right? So Redshift does need to bring their game up to match up with BigQuery and Snowflake in that area. Whereas the Snowflake has support for every kind of SQL statement that you might actually want to use. So that's great, right? So a clear winner over here is Snowflake when we compare these, right? But only if you have predictable workloads. If you have unpredictable workloads, then BigQuery clearly stands up, where you only pay for the actual reports or actual queries or jobs that you actually run on the database, right?
Can you repeat the last part? If you have unpredictable...
Oh, okay. So if you have unpredictable workloads, right, BigQuery stands out because they only process the jobs, right, and they only charge you for the jobs or the queries that you have run, right? Whereas in Snowflake and Redshift, if you have predictable workload, then use them because then you're actually paying for the compute for the whole day and you're using it fully as well. Right, so thank you guys. Thank you for attending this session. If you have any questions, please let me know. If you have any data needs or if you have any big data needs and you're looking for a solution for that, we at Python can help, right? So there will be people from Python around the hall, right? You can find anyone and talk to us and we can help, right? Thank you. If you have any questions, please let me know. Thank you.